big R would be this one, going from the axis of symmetry to the edge of the region, and the little r will be going just through the empty space. It is important when you're doing the washer method, so this thing that you're revolving around, it could be below the region, it could be above the region, it could be to the left of the region, or to the right of the region. I always recommend to draw your radii from the axis of revolution, just to kind of make sure you line things up correctly. And what I mean by that, like I'll start at the x-axis and go to the edge of the region, and then start at the x-axis through the empty part of the region. But again, this is going to be directly like what we did yesterday. We now just have a bunch of holes in the center, so we have to kind of take into consideration that hole in the middle when finding the volume. So I really just have, it's like 5 questions all relating to the same region, because students tend to pick up with this pretty fast, especially if they're okay with the disk method. So let's go ahead and just do this problem. This first one, there is really no calculus involved. I just want you to practice drawing these graphs by hand and finding the intersection points. So I have this region R, and we're going to stick with that same region R for every single example that we do today. And it's enclosed by the graphs of f of x and g of x. And I want you to sketch a graph of R and then find the x and y coordinates of any points of intersection. For this one, I might actually recommend finding the intersection points first before trying to do the graphs, just so you have an idea of what it might look like. But we do have like a line, pretty easy to graph, and then we do have like a square root function that has been translated some. But I would recommend finding the intersection points algebraically first. So go ahead and do that for me on your own just to practice, and then use that information to kind of draw a graph of it so you can kind of visualize what that region is going to look like. But I'll give you a second to try that first. All right, guys, let's talk about how I found my intersection points algebraically. We know to find the intersection points, you want to set the 2 graphs equal to each other. Different routes you could take to solve it. You could square both sides first. I went ahead and divided by 2 first, just so I had smaller numbers to deal with. Then to get rid of that square root sign, square both sides, making sure I FOILed the x minus 2. I saw that I had a quadratic function, so I did want to get it equal to 0, and then factor so that I could solve it correctly. I get x is 5 and x is 2. I do want to find the x and y intersection points. So I can take those 2 x values I found, plug it into either equation, and then I found that the points of intersection would be at 2, 0, and 5, 6. So I knew that these graphs were intersecting there. The line is pretty easy to draw, 2x minus 4, so it's a line with the y-intercept of -4, a slope of 2. The radical function might be a little bit harder to do. The ways that I think about this one is like there's no plus or minus on the outside. So like it's not been shifted up or down any. There are some stretches and like shrinks involved. Specifically, you can figure out the transformations of it. Like if you factor out that 3, I think it makes it a little bit more obvious. That -2 does tell you that you're moving it over to the right by 2, which we kind of saw that with the intersection point. But this graph, if you draw it accurately, even if it's just a sketch, would look something, if I can connect these, something like that. So the region we're looking at is that little sliver right there. So no calculus involved yet, but I do want to kind of talk about this region, like things we've already learned how to do. We know how to find like the area of that region if we need to. We also know how to do if this was like a volumes by cross sections, we could also do that pretty easily. This is one where if you're going to revolve it around any horizontal or vertical line, you are going to have to do the Washer method. So before we get into the calculus, let's kind of talk about when we know we have to use the Washer method. I know the first problem I'm going to do is when I revolve this around the x-axis. And before I have you kind of try that on your own, you can kind of see, well, if I spin that region around the x-axis and it's going to trace out this volume in this circular motion, you have all this empty space where the region is not touching what it's kind of spinning around. Whenever you have that empty space there, that's your clue you're going to have to use the Washer method, because you are going to have to like subtract out that empty space. So go ahead and like finish the problem. Like I'll change it so you can actually see what I want you to do. Same region. There's R. I went ahead and just used my computer to kind of do the region. I just want you to write an integral right now that would represent an expression for that volume when revolved around the x-axis. And again, we know we're going to have to use the Washer method because they don't touch. You need to be able to find like what the big R is and the little r is. And again, I recommend when you're drawing your radii, move from like the axis of revolution. So the further one you go out to would give you your big R. The empty space inside of it is going to be your little r. So go ahead and try that one. And then we're just going to keep trying more examples of this revolving this region about different lines.
So for the little arms, you're finding
It's going to be like,
the area?
it's going to, well, you're still setting up the little r is going to be the length of the empty space. So it's still going to be like what we did for all the other ones, like top minus the bottom. So as we're looking at this one, we are going around the x-axis. So when I draw in those radii, when I'm moving up and down, since my radii are moving up and down, is this going to be in terms of dx or dy? dx. If I'm in terms of dx, then I do want the x values on my integral sign. This region started at 2. We found that on the previous slide and ended at 5. And again, we found that on the previous slide. And then we do just want to kind of set up the Washer method. I kind of wrote it in purple, like you can either have that pi factored out or write the pi next to the r squared. So I'm going to go ahead and leave it on the inside, but I have pi, and then I'm going to have the big R squared minus pi little r squared, and we are with respect to dx. Similar to what we've been doing on this whole unit, to find the length of something, either top minus the bottom or right minus the left. We are in terms of dx, so it is going to be top minus the bottom. Some mistakes I see, students are often used when they do like top minus the bottom, they think of like the top function and then the bottom function of the region, but you want to be careful and look at the radius. When we say top minus the bottom, you have like the top function of the radius minus the bottom function of that radius. So what is the top one? Is the square root function. They named it f of x, so I can be lazy and just call it f of x. So I would have f of x minus the bottom function, which would be y is equal to 0. And then for the little r, its top function is the line, which we call g of x. Its bottom function is the x-axis, which is y is equal to 0. And of course, you could have left off the zeros there, would have gotten the same answer. That's just kind of the expanded version of it. But that would be your answer. Questions on that one?
For the big R, wait, why isn't it like,
Because big R, you have to think about what's the top of the radius, which is f of x, and then the bottom of the radius, which is the line. You're thinking basically like the top y value minus the bottom y value.
so like if f of x minus g of x, that was when we did like,
That would be if I just wanted to find like the length through just the region. But the radius has to go all the way down to the axis that we're revolving it around. Same region, try that one now. So I have the region R, same one, same intersection points. This time we are revolving it around the line x equals 6, that vertical line. Clearly, this one should be the washer method. There's a huge gap between the region and what we're revolving it around. There's going to be like this big hole in the middle. Go ahead and write an expression for the volume of that for me. And this one might take some time because you are going to do this one in terms of dy. So just make sure you put everything in terms of dy.
You're right, ignore.
And so let's talk about how I knew this one was going to be in terms of dy. Like if I'm revolving it around a vertical line, then if I draw my radii, going from the axis or revolving it around, through the empty spaces little r, all the way to the edge of the region is going to give you your big R. Since your radii are moving left to right, you know that we are going to do this in terms of dy. If we're doing it in terms of dy, we do want y values on our integral sign. Already found these. This is starting at the y value of 0 and ending at the y value of 6. And then we do want to go ahead and find expressions for big R and little r. Since we are moving kind of like back and forth, left and right, we do want to kind of write it as the right one minus the left one. So looking at big R, the right function is x is equal to 6. So you would have 6 minus the left one, which would be the square root function. In terms of y, I got 1/12 y squared plus 2, or any equivalent way that you kind of rewrote that. And then for little r, the 6 is the right function, and then the left function is y plus 4 over 2. Again, technically, mathematically, if you accidentally flipped the left and the right, you would get the equivalent answer because you are squaring things to become positive. But that is how they would be written on the AP exam. And again, you could have that pi factored out as long as it was clear that it would distribute to both the big R squared and the little r squared, which is often why I would just write them beside it just to make sure it's clear. Because again, this is really just based off the idea you're doing like the big circle minus the little circle. Questions on that one?
Mr. Brown,
Yes.
Does it matter if you went from left to right?
It technically doesn't matter since you're squaring it, it's gonna become positive anyways, but I would just make sure you're in the habit of doing right minus the left.
Mm-hmm.
Because it can mess you up when you're just doing area.
Thank you.
All right, guys, last slide. Try those two for me. Same region. Oops. There we go. So I have region R. In part B, you're going to revolve it around the y-axis, right? An integral expression representing that volume. And then part E, same region, but I have a horizontal line above it at y is equal to 6. Just write an equation representing the volume of that one as well. And I should have copied my graph over. And thankfully, in AP exam, a lot of these are just like set up and leave it as is, because they usually just have a bunch of messy algebra to evaluate by hand, which is not what the AP exam wants to test. It just wants to test, do you really know the calculus, which would be a lot of just like set up and leave it as is. And so like all these are the Washer method, like if ever your region lies flat against what you're revolving around, then it would just be the disk method because you wouldn't really have like a big R and a little r. Looking at D, just to kind of talk about it, if you're going around the y-axis, I know that there's a lot going on in that diagram, but looking at the green, that would represent what we're looking at D. The little r is always like the empty space you end up subtracting. So from the y-axis to the curve would be little r. Big R will be always from what you're revolving around to the edge of the region. So it's going to go to the line. Since in D you're going back and forth, D you should be doing in terms of dy. Likewise, looking at E, if we're revolving this at the line y is equal to 6, that is above the region, but we are still going to be revolving kind of up and down in terms of the radii. Again, little r would be the empty space. And then big R will be from the axis all the way to the outside edge. Since you're doing it in terms of dx, you would think about writing your r's, your radii, as like top minus the bottom. I'm going to give you a few more moments to finish trying those, and then we'll look at the answers, and that's basically where we're going to end today's note.
Mr. Brown,
Yes.
for part B, could we have done that that volume the same way as we learned yesterday?
None of the ones I did today in the notes could you use the disk method because the region is not lying completely flat against the axis.
All right.
So you asked about D or B, you said,
B.
right? Or which one? Say it again.
B, as in
B.
boy.
So yeah, this one you had to use the disk method because like, yes, it's touching right at that corner, but you still have all this empty space when it's wrapped around. So it's kind of still gonna be like a hollowed out figure.
All right.
So, and if it helps, you can kind of imagine what it looks like when it makes it to the other side. So like it's this weird looking bowl, but it is empty in the middle, so you would have to use the washer method.
All right. Thank you.
All right, guys, and there's the answer you should have gotten for D and E. I was lazy and kind of already typed it in. So looking at D again, we knew it had to be in terms of dy. We had the right function minus the left. the 0 is coming from, because the left function would have been, of course, the y-axis, x is equal to 0. And then for part E, I did type in the functions. Since they named it, you could have also just used f of x and g of x. You're always allowed to call a function by its name if it has been named specifically on a question. And this one was in terms of dx, so it would have been top minus the bottom. The top function was y is equal to 6, and then the bottom one, you can see depending on big R, little r, was a function. And again, thankfully, then I have to evaluate those, because it would just be messy algebra. Other than that, any questions on the disk method? All right, so 2 o'clock, see, said I would finish right at 2. So what I want you working on today, again, like this hopefully feels like an easy unit to you, like it should be, like it is very formula-based, as long as you can kind of figure out the different pieces that you have. So yesterday, I assigned homework 4. Hopefully you were able to get a lot of homework 4 done, since it was only those 8 questions. Today, I am going to go ahead and assign homework 5. I will say not all of them are the wash method. There are a few disk methods thrown in, just so you're kind of aware and have to think about what it looks like. Since I'm really concerned in this unit, like, can you just set up the integral for homework 5, especially since you probably did most of homework 4 by hand, I am perfectly fine if you use your calculator for every single problem on homework 5. Looking ahead for the rest of the week, tomorrow is just going to be a work day. It is a shortened period already, so I didn't want to have to like teach something new on Wednesday. There is an optional homework. It's going to be optional homework number 6. I do strongly recommend it. I just like with the time and like honestly, this unit is very repetitive. Many of you can probably be fine without having that homework 6 as practice. I would recommend at least picking a page out of homework 6 and doing it before your test, because it does mix together everything from like area, volume by cross sections, and then volumes of revolution. Thursday, what we're going to be looking at is arc length. It's going to be the one BC only topic that we have this unit, of how we find the actual length of a curve. It's just going to be another formula. Then you have the long weekend. I don't know why I call this Thursday and Friday, but Tuesday is going to be a review day, and then Wednesday, the 17th, is going to be your test. Do notice that I only have one day for like the briefcase binder and review this unit. So tomorrow could also be a good day to kind of start filling in some of your briefcase binder stuff as well. But that's kind of what the week is going to look like. Again, tomorrow is just going to be like a day for you to work and ask me questions and for us to kind of go over stuff before we move into the last topic on Thursday. That being said, if you're at home, definitely hang back if you have questions you want to get answered. But if you're good to go and just working on homework, then that's fine.